Good morning, children. Children, let me continue some more numericals in this unit solutions. Now I'll take up the next concept. What is that? Osmotic pressure, and I'm going to solve some of the numerical under osmotic pressure. Under that, number one, if 1.71 grams of sugar, molar mass is equal to 342, is dissolved in 400 centimeter cube of a solution at 300 Kelvin, what will be its osmotic pressure? Given R value is equal to 0.0821 liter bar per Kelvin per mole. Children, read the numerical for 2 times, then you write down whatever the data given here. Remember, 1 centimeter cube is equal to 1 ml. That means 400 centimeter cube is equal to what? Is equal to 500 ml. That you need to keep it right. Let me solve this numerical solution. So given data. Now volume is given. How much here? It is 500 ml or centimeter cube. Right? That means I'll convert this into liter. Look at here. Then I'm going to get 0.5 liter. Is it not? Then what else is given? Please look at here. WB is given. WB is equal to 1.71 gram. And MB is given. MB of sugar, what is that? It is 342 unified mass, otherwise gram per mole. Children, temperature is given. Temperature is equal to 300 Kelvin. Is it not? And then R value is given. How much? 0.0821 liter bar per Kelvin per mole. Okay, then what are you supposed to find out? You are supposed to find out osmotic pressure. Children, you know the Van 't Hoff equation for osmotic pressure, is it not? What is that? Please look at here. According to Van 't Hoff, equation, Y is equal to CRT, or Y is equal to concentration N by V into RT. Is it not? Or Y is equal to WB into RT upon, yeah, you're right, MB into V. So this is what we have learned under osmotic pressure and the formula required for the determination of osmotic pressure by using Van 't Hoff equation. Okay, children, once you know this formula, now it is easy for me to go for solving. Now what do? I'll substitute the value. Now WB is how much here? WB is equal to 1.71. R is equal to 0.0821 into temperature is how much here? 300 Kelvin upon MB is how much here? MB is equal to 342. Is it not? Sucrose. And volume is equal to 0.5. Children, if you simplify, you are going to get 0.249 bar, otherwise called atmosphere. So this is what osmotic pressure for you. Let me go for the next numerical. 100 milligram of protein is dissolved in just enough water to make 10 ml of solution. If this solution has an osmotic pressure of 13.3 mm mercury at 25 degrees Celsius, what is the molar mass of the protein? Look at here, R is given 0.821 liter atmosphere per Kelvin per mole, and one more is given here, 760 mm is equal to 1 atmospheric pressure. Why they are given here? Because the osmotic pressure is given in terms of mm mercury. That you need to convert into atmospheric pressure or bar, whatever. Look at here. This is an int. Now, mm mercury divided by 760, then you are going to get 1 atmospheric pressure or 1 bar pressure. One more term I am going to introduce here. What do you call this? A torrent. Torrent upon 760 is equal to 1 atmosphere, otherwise 1 bar. Remember, torrent abbreviated as TORR. This also you should know. They may I give either in mercury or torrent, that you need to convert into atmospheric pressure or bar pressure. Hope you understand that. With that, let me take up this numerical. Solution. Let me write the given data. Given data. Children, they are saying here 100 milligram of protein. That means WB is given. How much? WB is equal to 100 milligram. Children, if it is in milligram, you need to convert that into grams. How do I convert this? Look at here, 100 into 10 to the power minus 3 grams. Hope I are getting that. Okay, and what else is given? R is given. How much? 0.0821 liter atmosphere per Kelvin per mole. Is it not? Then what else is given here? Just see here. Temperature. Temperature is how much here? Temperature is equal to 25 degrees Celsius. Now convert it into Kelvin. What do? You add 273 for that. Look at here. 25 plus 273. You are going to get 298 Kelvin. Hope you are following. Right now? Then we go for the volume. V. How much? 10 ml is given. You convert that into liter. Okay? 10 ml. Now convert that into liter. What do? 10 into 10 to the power minus 3 liter. Hope you are getting that. Okay? Next, pi is given. Osmotic pressure. How much? 13.3 mm mercury. Is it not? Now that you need to convert into atmospheric pressure. 13.3 upon 760, that you gives the atmospheric pressure. What are they asking? They are asking to find out the molar mass. They are asking to find out MB. That you need to find out. Now, you know the formula for osmotic pressure, right? By which you can calculate molar mass. Pi is equal to WB into RT upon MB into V, volume. Now, what are you supposed to find out? MB. Look at here. MB is equal to WB is how much here? 100 into 10 to the power minus 3. R is 0.0821 into T, 298 Kelvin upon MB is how much here? MB. Not we need to calculate, is it not? And pi will come here. Pi is how much? 13.3 upon 760 into volume is how much here? Volume is equal to 10 into 10 to the power of minus 3. Okay, children, I'll simplify this. 100 into 10 to the power minus 3 into 0.0821 into 298. So this will go for the numerator, 760 upon, following or not? Upon 13.3 into 10 to the power of minus 3. Children, you need to simplify that. When you simplify that, you are going to get, look at here, 1398 unified mass or gram per mole. Look at the molecular weight is very high. Tell me why? Because you are calculating the molecular mass or the weight of proteins. Children, in this I forgotten that why there is a huge value of molecular mass over here. Very simple. Whatever the polymers you are going to study, they will be having high molecular mass. As we are taking protein, that is why the molecular mass is also very high. Let me go for the next numerical under osmotic pressure. A solution is prepared by dissolving 8.95 milligram of a gene fragment in 35 ml of water, has an osmotic pressure of 0.355 torr at 25 degrees Celsius. Assuming a gene fragment as a non-electrolyte, determine its molar mass given R is equal to 0.0821 liter atmosphere per Kelvin per mole. Children, one clue is given. Look at here, gene fragment as a non-electrolyte. Remember, if it is a non-electrolyte, there is no question of Van 't Hoff factor I. If it is an electrolyte, then only we need to introduce insert Van 't Hoff factor I while calculating the molar mass. So So that is what you have learnt under abnormal molar mass and the Banter factor. Now let us solve this numerical solution. Let me write down the given data. Look at here. A solution is prepared by dissolving 8.95 milligram of a gene fragment. WB is equal to 8.95 milligram. I need to convert that into grams. How do I do? 8.95 into 10 to the power of minus 3 gram. Now what else is given? See, volume is given. How much? It is 35 ml. Is it not? That I need to convert into liter. 35 into 10 to the power of minus 3 liter. What else? Pressure is given. Osmotic pressure. Pi is equal to how much? 0.355 torr. I said 1 torr is equal to 1 mm mercury. Is it not? Now 0.355 upon 760, then you are going to get the atmospheric pressure. Then temperature is given. How much? 25 degrees Celsius. Convert that into Kelvin. 25 plus 273, you are going to get 298 Kelvin. What else is given here? R is given. How much? It is 0.0821 liter atmosphere per Kelvin per mole. What are they asking? They are asking to find out MB, molar mass of the gene fragment. Now, you know this, you learnt under biology, genes are basically composed of what? Proteins. That means you are going to get huge molar mass for this calculation. Let me find out. You know the formula. Pi is equal to WB RT upon MB into volume. I'll reshuffle. MB is equal to WB RT upon pi into V. I'll substitute the value. What is WB here? WB is equal to 8.95 into 10 to the power of minus 3, or you know the 0.0821 into T, you know 298. Is it not? Pi is how much here? Pi is equal to 0.355 upon 760 into volume is how much here? Volume you will calculate. Look at here, 35 into 10 to the power minus 3 liter. Now, so this 760 will go in the numerator. Look at here, 8.95 into 10 to the power minus 3 into 0.0821 into 298 into 760 upon 0.355 into 35 into 10 to the power minus 3. Children, if we simplify that, we are going to get 14,223 gram per mole or unified mass. So that is why I said, as it is a gene which is protein, you are going to get a huge molar mass. Children, you can also write 1.42 into 10 to the power 4. That is also correct. Children, let me give two numerical for homework. 10 grams of an organic substance when dissolved in 2 liters of water gave an osmotic pressure of 0.59 bar at 7 degrees Celsius. Calculate the molar mass given. R is equal to 0.0821 liter atmospheric pressure or bar per Kelvin per mole. Remember, 1 bar is equal to 1 atmospheric pressure. Okay. So next one. 3 grams of a non-volatile solute when dissolved in a liter of water shows an osmotic pressure of 2 bar at 300 Kelvin. Calculate the molar mass of the solute. R value is given 0.0821 liter bar per Kelvin per mole. Hope you can solve both the numerical easily. Let me go for the next numerical of a different type. Let me go for the next numerical, children. A solution containing 15 gram of urea with molar mass 60 gram per mole per liter of solution in water has the same osmotic pressure, that is isotonic, as a solution of glucose with molar mass 180 gram per mole in water. Calculate the mass of glucose present in 1 liter of its solution. Children, one clue is given. What is the clue here? Clue is isotonic solution. What means isotonic? two solutions of different substances having the same osmotic pressure are called isotonic solution. That means in this numerical, solution of urea is isotonic with solution of glucose. What are they asking? They are asking to find out WB of a glucose present in 1 liter of solution. Very simple. Let me take up this numerical. Children, we know that pi is equal to WB into RT upon MB into V. Is it not? Let me take up for the first one. I'll go for urea solution. For urea solution. Children, for urea solution, look at here, WB is equal to how much? 15 gram. Is it not? And MB is equal to how much? MB is equal to 60 gram or unified mass. And volume is how much here? Volume is 1 liter. What is that? 1 liter. Is it not? Now, let me put this formula here. Pi is equal to, what W here? WB is equal to 15 into RT upon MB is how much here? MG is equal to 60 into 1. Hope you're following. Right? Similarly, let me write for glucose solution. For glucose solution. Children, in this case, WB you are supposed to find out. Volume is given how much? 1 liter. They are getting or not? And MB is given how much? MB is equal to 180 unified mass. Now I'll substitute the value in this equation. What I'm going to get? Pi is equal to, okay, so WB you need to find out. I'll keep it as it is, into RT upon 180 into 1. Children, remember, for isotonic solution, osmotic pressure of urea solution is equal to osmotic pressure of a glucose solution. In that case, what I do? I go for equating both the equation I got here. One for the urea, one for the glucose. Please look at here. Equating both the equations. 15 into RT upon 60 into 1 is equal to WB RT upon 180 into 1. Is it not? What you're supposed to find out? You're supposed to find out WB. Children, in that case, look at here, 60 into RT into 15 into 180 into RT. Is it not? Children, if you simplify this, you are going to get WB is equal to 45 grams. What is WB here? Glucose. That means 45 grams of glucose need to be dissolved in 1 liter of water to get osmotic pressure, which is equivalent to urea solution, which is prepared by dissolving 15 gram of urea in 1 liter of water. Let me go for the next numerical. A solution containing 10.2 grams of glycerine per liter is found to be isotonic with 2% solution of glucose. Calculate the molar mass of glycerine given molar mass of glucose is equal to 180. Very simple, children. You know the formula. What is that? Pi is equal to WB into RT upon MB into V. Is it not? Now, what is the clue here? Clue is isotonic solution. That means the glycerine solution and the glucose solution are isotonic. That means they have the same osmotic pressure. Let me write for glycerine solution. Look at here, WB is given how much? 10.2 grams. Second one, volume is given. What is that? 1 liter. And what else is given? MB you are supposed to find out. Is it not? Now I'll write here pi is equal to WB is 10.2 into RT. I'll keep it as it is upon the MB you are supposed to find out. V is equal to 1 liter. Volume is equal to 1 liter. So let me write for B for glucose solution. Glucose solution. Here you need to be careful. WB, what they say here? 2% solution. 2% solution. That means, children, remember, when it is 2% solution, 2 grams of glucose dissolved in 100 ml of water. That you need to remember. Hope you are getting that, right? Now WB is equal to 2 grams. In that case, WB is equal to 2 grams. Hope you got it. Now, volume is equal to how much? 100 ml. Now convert that into, what is that? Liter. That is equal to 0.1 liter. Hope you are getting that. Then MB is given. MB is equal to how much here? It is equal to 180 unified mass. What are you supposed to calculate? You are supposed to calculate molar mass of, what is that? Glycerin. Now, as I said, it is isotonic solution. For isotonic solution, osmotic pressure of a glycerin is equal to osmotic pressure of glucose. That means you need to equate both the equation. Let me write pi is equal to, look at here, WB is equal to 2 gram into RT upon, what is that? 180 into 0.1. Now I'm going to equate. Isotonic solution. So equate both the equations. Look at here, 10.2 into RT upon MB into 1 is equal to 2 into RT upon 180 into 0.1. Okay. Now, so what you have to find out? MB. You are supposed to find out the MB is equal to 2 into RT. So 10.2 into 180 into 0.1 into RT. Cancel this. Children, if you simplify this, you are going to get 91.8 unified mass, otherwise gram per mole. Gram per mole. Either you are expressing in terms of unified mass or gram per mole. Anyone is sufficient for that. Let us solve this numerical solution. Let me write the data first. Look at here. Calculate the amount of NaCl which must be added to 1 kg of water. That means W is equal to 1 kg. That is equal to 1000 grams. Is it not? Then what is the given here? So that freezing point of water is depressed by 3 Kelvin. That means delta TF is given. That is equal to 3 Kelvin. Now what else? Water, freezing point of water. That means TF not, how much? It is 0 degree, otherwise 273 Kelvin. Is it not? Hope you're getting that. Okay. What else is given? Kf is given. How much? 1.86 Kelvin kg per mole. Is it not? And you find out molar mass of solute. How? That is NaCl. Is it not? NaCl. How do you find out? That is 23 plus 35.5 is equal to 58.5 unified mass. Formal unit mass you have to find out. Hope you are getting that. Right? Now, what are they asking here? They are asking to find out WB. And you know that I is what here? I is equal to, I'll write here, I is equal to 2. Why? The Van 't Hoff factor for sodium chloride is equal to 2 because each particle of sodium chloride dissociates in water to give 2 particles. One Na plus and one is Cl minus. Children, now you know the formula for depression in freezing point. And look at here, depression in freezing point delta TF is equal to, you know the formula, what is the formula? KF into WB into 1000 upon MB into WA. Now children, as it is an electrolyte which undergo dissociation, we need to include Van der factor. You have to modify the formula for the colligative property. Look at here, I modified depression in freezing point by inserting the Van der factor I. Hope you got it. Right? Now, what are you supposed to find out? You are supposed to find out WB. Is it not? Now, look at here, WB is equal to MB into WA upon I into KF into 1000 delta TF. Now I substitute the value. MB is equal to how much here? MB is equal to 58.5 into WA is how much here? WA is equal to 1000 grams into delta TF is equal to how much here? Delta TF is equal to 3 Kelvin upon I is equal to 2, KF is equal to 1.86 into 1000. Hope you are getting that, children. If you simplify this, you are going to get 47.17 grams. It is WB is equal to 47.17 gram. That means 47.17 gram of sodium chloride must be added to 1 kg of water so that freezing point of the water is depressed by 3 Kelvin. Children, the second numerical on Van der factor is very similar to that of the first one. You can easily solve that. Let me take up what mass of sodium chloride. Molar mass is equal to 58.5 unified mass must be dissolved in 65 grams of water to lower the freezing point by 7.5 degrees Celsius. The freezing point of depression constant for water is equal to 1.86 Kelvin kg per mole. Assume Van der factor for sodium chloride is equal to 1.87. Children, very simple. Let me solve this numerical for you. Solution. Let me write the given data. Look at here, I is given. I is equal to how much here? 1.87. Is it not? And MB is given. MB, how much? 58.5 gram per mole or unified mass, whatever. Right? WA is given. Weight of water, that is 65 grams. 65 grams. Children, delta TF is given. Depression in freezing point, how much? It is 7.5 degrees Celsius. Remember, if it is given in degrees Celsius, keep it as it is. Don't convert that into Kelvin. If it is given in Kelvin, you take it as Kelvin. If it is given in degree centigrade, you take it as degree centigrade only. No need to change. Hope you understand that. KF is given, how much? 1.86 Kelvin kg per mole. And what else is given? Look at here. Almost all covered, right? Now you are supposed to find out WB. Children, you know the formula. What is that? Delta TF is equal to, now I need to include I, Van der factor. I into KF into, WB into 1000 upon MB into WA. Look at here, what do you want? WB. I'll reshuffle. Is it not? I into KF into 1000. Here, MB into WA into delta TF. Now put the value here. It is 58.5 into WA is how much here? WA is equal to 65 grams. Delta TF is equal to how much here? 7.5 degrees Celsius upon I is equal to 1.87 given. KF is equal to 1.86 into 1000. Hope you are following. Children, If you do this, if you simplify this, you're going to get 8.199 grams. Alright, yeah, 8.199 grams. Children, let me give one homework for you on Van 't Hoff factor. Calculate the amount of KCl which must be added to 1 kg of water so that the freezing point is depressed by 2 Kelvin. Given Kf of water is equal to 1.86 Kelvin kg per mole and atomic mass of potassium is equal to 39 and the chlorine is equal to 35.5. Very simple numerical, you can easily solve. Even then, look at here. KCl, when dissolved in water, it undergo dissociation to form K plus and Cl minus ions. Why? Because it's an electrolyte. If I take 1 mole of KCl, there will be 1 mole of K plus ion, 1 mole of Cl minus ion. Together, there will be 2 moles. Remember, with 1 mole of KCl, you are going to get 2 moles of K plus and Cl minus ions. Hope you are getting that. That means I is equal to 2. Why? I is equal to total number of particles after dissociation upon number of particles before dissociation. After dissociation equal to 2 and before dissociation is 1. So 2 by 1 is equal to 2 here. I is equal to 2. And MB, molar mass of KCl. How do you get that? You add 39 plus 35.5. You are going to get 74.5 unified mass. With this, you can easily solve the numerical which is written on the board.